as we talk about the definite integrals today, we do not, I don't want you to think about this from the lens of I took Mrs. Turner's class, but rather this is my first calculus class. Okay? All right. Now, so if I gave you this particular integral to evaluate, what would you do?
Upper minus the lower, whatever.
Raise the power of the...
Oh, so that, all right, so you're saying this is equivalent to x squared
Yeah.
plus c is as far as we've gotten, yes? I don't know that we've evaluated it with bounds yet. I don't think I've taught you how to evaluate it with bounds yet. I don't think. In fact, I feel like we've really only learned 2 different strategies. Does anybody have an idea of what you would like to do to solve this integral?
Plug it in my calculator.
Oh, I haven't taught you about Math 9 yet. Though certainly, since you know about Math 9, you could, here, Seamus, I got it. Hold on. So what do I do? Oh boy, guys.
I don't know.
You have no idea?
I'm scared.
How about we take the limit as n goes to infinity of the summation of k equals 1 to n of, well, shoot. For that, we would have to have, like, what is delta x and what is c sub I, yeah? What is delta x? It would just be, well, it's a minus b, or it's b minus a, so it's the top boundary minus the lower boundary, yes?
So 3 over n.
So it would be 1 minus negative 2 is 3 over n. Right? Is that we have that interval between negative 2 and 1 is 3 units wide, right? And we're splitting that up into n rectangles. And then what would c sub I be?
Isn't it a times something a? I know there's something for it.
C sub I, you guys, is a plus k delta x.
That was close.
So what is a in this particular case? The bottom bound. The bottom bound, yeah? Plus 3k over n. All right, and so then we do f of c sub I would be 2 times negative 2 plus 3kn. That's 2x, right? Times delta x, which is 3 over n. So would you guys be okay if I distribute a 6 over n? Between this 2 and this 3, those equate to 6 over n, and then I'll multiply that by the inside. Is everybody good with that? So I would get the limit as n approaches infinity of the summation of k equals 1 to n of negative 12 over n plus 18k over n squared. Well, so as you say that, yes, I'm gonna. That's what we're doing. However, there's a little bit more to it than that. What we're going to do is evaluate the summation in terms of n. Okay, so we'll still have the limit as n approaches infinity. You guys, this in terms of n, this is a constant. What is the formula for a constant? You multiply it by? It's the constant times n. So you would have the negative 12 over n from the formula, and then you would multiply that by n because of that formula. Plus 18 over n squared, and then the k becomes n plus 1 over 2. And then I'm just going to rewrite that numerator as 18n squared plus 18n. Because it'll make my simplifying later on make a little bit more sense. Yeah.
This is not relevant. Is that area thing down there like just a formula, or like is that space we need to save for later?
I wouldn't worry about it.
Okay.
Are we good? So what's my limit? -3. Great. Now, I said I taught you 2 ways to do this. You guys chose the harder one. What's the easier one? Let's just graph this real quick. Essentially, that integral is equivalent to these areas, yeah? Do you guys see what I'm saying? And in this particular case, because this is linear, I would not choose to do this using the limit notation. You guys, what's this area? This would be 2. This would be 4.
Maybe 4. -4.
-4 since it's below the axis, yeah? What's the other area?
1.
This would be 2, or this would be 1, this would be 2, this would be 1. What's my net area?
That area is -3.
-3.
So wait, we really don't need we need the bounds for the graphing part, but like you can technically solve this.
This one, yes.
Yeah.
For sure. This one, yes.
Okay.
And what about this one makes it easy to solve?
Equals 1.
Linear.
The fact that it's linear means it's making nice, easy shapes to find the area of.
If we get something like this, how do we know whether it's going to be like the bounds are important or not in terms of solving it? Like, let's say I went with the way on the left, not just looking at.
We use the bounds
Okay.
because that's how we got the 3 over n and the 3k over n and the -2.
By using the bounds.
Yeah.
How do
The
we-
bounds influence these 2 things,
Oh, the A and the B. Okay, that's what I was.
right? So like you can't do this without first recognizing that the bounds tell you what delta x is, right? And then they also are related to C sub I as well. Everybody good? Okay. So, is there any reason if on a quiz or a test, if I gave it to you this and you solved graphically, using the graph is showing analytic support. And as long as what I give you is linear or an easy area to do, I don't have a problem with it. Everybody good? Okay. Turn the page. When we get to one like this one, when I get to this one, well, You guys, what does the graph of 4x minus x squared look like? It's a parabola, because it's got an x squared in it, right? It's upside down. And if I want to find the x-intercepts, I could factor out an x, just to figure out where does it equal 0, right? Because x-intercepts are where the y-coordinate is 0. So at x equals 0 and x equals 4, and the bounded area between this function and the x-axis is this one. We still have area between the function and the x-axis, like right here is between the function and the x-axis, but that is unbounded, because it goes on forever and ever and ever. So when we're talking about bounded, this is the secure area in between here. Yeah. Now, does this follow a typical shape for us to do? No. So can I just graph this? No. This is one where you would have to, until tomorrow, okay? Until tomorrow, use that limit definition. Everybody good?
Can we do it?
Well, we have no bounds.
What would the bounds be?
Oh, maybe
0,
0 and 4.
4.
So now this is recognizing if I want to find that area, my bounds would be between 0 and 4. 4x minus x squared dx. When I start asking you to find areas and you're doing setup statements, I will be really picky if you drop your dx. Like really picky. Because you can't integrate without the dx. Everybody good? Okay. What's delta x? 4 over n. C sub I? 4k over n.
Does no one else keep running N? I'm thinking it says Katie.
I do it a lot too.
And that C sub I, just plug it in for x in the function.
Mm-hmm.
Okay.
Because the general form is that you're taking the limit as n goes to infinity of the summation k equals 1 to n of f of c sub I times delta x.
It's been 4 days a week.
Sure. That's one of the reasons we're talking about it, yeah?
B over N. How do we get delta x? Or A minus.
Delta x is b minus a over n, and c sub I is a plus k delta x. No problem. There's a lot to it, yeah? And I get 64 over n squared. 64k over n squared minus 64k squared over n cubed when I simplify. When I simplify all the way down. This one is 4 times 4 and distribute this 4. This is 4 squared times this 4. That's where both 64s come from. N and n is n squared. This n is being squared, and then this n is n cubed. Everybody good? So I have 64 over n squared. What happens to the k? It becomes n plus 1 over 2. Again, I'll give you guys those. You don't need to memorize them. Okay? Plus, minus the 64 over n cubed. And then the k squared becomes n plus 1, 2n plus 1, all over 6.
How did they come up with those things?
I've never read the proof. Somebody wrote a proof for it at some point. I know the proof for this one. I can do that proof. This one, I don't know that I got. I have some ideas. Thank you for giving me a new challenge
You're welcome.
for the weekend, just for fun. Doesn't that sound like fun to you guys? No?
It would be a
It's way easier. It's so much faster.
64 times 4. I should know that.
64 times 4?
Oh, it's supposed to be.
Are you doing 64 times 4?
I probably messed it up.
So here's what, for that first set, you guys, I would cancel the 2 and the 64, and then I would distribute 32n. So I'd be taking the limit as n goes to infinity of 32n squared over n squared plus 32n over n squared. For the second one, we got a whole mess. Just this piece becomes 2n cubed.
Where does the plus 1 go?
I distributed the 32, so I took 32n.
Yeah, 32. So 32n squared plus n.
So the 32n is being multiplied by the n plus 1, yeah? 32n times n is 32n squared.
Yeah.
32n times 1 is 32n.
Okay, so that's all in the first one.
Mm-hmm. I'm gonna have so much fun writing that proof. Are we good? So then we have plus, and then so I would have, if I distribute that 64 to the 2n cubed, that would be 128 n cubed, and on the bottom I would have 6n cubed.
What do we do about the minus?
Oh, it's actually minus. I made that mistake this morning too. It's actually minus. And that minus is going to get distributed with that 64. And then, so then I would have minus 64 times 3 is 192 n squared over 6n cubed minus 64n over n cubed.
Would it be 6n cubed or no?
Oh, yeah, it doesn't. It's not 0. When I take the limit, it's going to be 0.
That's fair.
Yeah. Which means once I take my limit, I have 32 plus 0 minus 128 over 6 minus 0 minus 0. I think it's 32 thirds. 32.
128/6.
32 minus 128/6.
I see that.
Great. Guys, I promise the hard part's done. Okay. Guys, I want to talk about like the integral of cosine x in between pi and pi. What's my delta x if I am between pi and pi? 0. So what's going to be my summation?
0.
0. Now, visually, you guys. Y equals cosine x looks like this. Yeah? And my interval happens at pi, between pi and pi. You guys, what's the area between my red and my blue? If the width is 0? 0. So if you're asked to do an integral where the bounds match each other, your width of your bounds is 0, the area is 0. Everybody good? All right, now let's look at this one real quick. Does that look familiar? What happened?
The bounds flipped.
The bounds flipped. So if we think about this from the analytical perspective, delta x is now going to be negative 4 over n. The rest of it, that negative isn't going to matter as n goes to infinity. Is everybody with me? So the only thing that changes is everything in the summation becomes negative, because the delta x becomes negative. So, what is this answer? Negative 32 over 3. So if you know from 0 to 4, then 4 to 0 would be the negative of that. Questions? Perfect. How would you do this one? Could I integrate it the way it's written right now? Not with absolute value, I can't.
Is there any way to cancel out absolute value?
What you would do is call this negative 2 to 0.
Say negative x dx for that.
Yeah, because the y value is the negative of the x value. On this, like here, if x is negative 1, y is equal to positive 1, right? So for the negative values in that interval, the absolute value of x is actually equal to the opposite of x. Like the absolute value of negative 2 is negative 2, which is 2. Yeah? Is the opposite. And then from 0 to 3 of x dx. So if we were solving this analytically, we would have to split it up kind of into those two pieces. That being said, I would never in my life solve this analytically when I can say, or using the limits when I can say, oh, the area of this section is 2. 2 times 2 over 2. The area of this section is 9/2, because it's 3 times 3 over 2. I would use, if I can use an area model, I'm going to. Everybody good? I'm done for today. Be ready.